Hello everyone, Ismail is here. Today we're going to start a new lesson, 6.2, transforming quadratic functions. Okay, after we finish 6.1, transforming functions, we have here this warming up question, which is very important. Let's go through in these questions. You can find all the previous lessons on my website. Okay, now let's start doing these questions. Okay, now plot the functions. We have here two functions, f of x, x to the power of 2, and d of x equal negative x to the power of 2. Now, if I need to graph both functions, x to the power of 2 and negative x to the power of 2, from its name, so as we can see here, x to the power of 2, let's make tables, okay? So if we need to create the tables, x, y, so we have 0, negative 1, negative 2, and here 1, 2, okay? So always 0, 0 in the middle. So now if we substitute the numbers, okay, so it will be 4, and here 1, 1, and 4. So as we can see here, we can plot a 0, 0, 1, 1, here, 2 and 4, negative 2 and 4. So we can graph my points. Okay, so this is the graph of x to the power of 2. Now, if I need to graph negative x to the power of 2, so when I creating my tables, let me create the tables here. Okay, x and y. Okay, so now in the middle should be 0, 0. Okay, now when I'm substituting the negative signs, which is negative 1 or negative 2 or negative, so I know that, okay, now let me replace this one in the x. Okay, so now it will be negative 2 times negative 2 to the power of 2. I know that the answer inside this one is 4, but don't forget that I have a negative. So now my answer here should be negative 4. Same thing here if I need to replace the negative 1. So it should be negative 1, okay, to the power of 2 is equal 1. With a negative, it will be negative 1. Okay, same answer here should be because the axis of symmetry. So now if I need to graph this one, so my function, it will start from here, negative 1, and negative 2, negative 4, 2, and 4. So as we can see here, the function goes like this. Now, if we look here, okay, if you remember from the previous, if a is greater than 0, so my functions goes upward. And if my function is less than 0, all my functions will be downward. So that's what we can see in the function. This is positive function. This is negative function. Okay? So that's the difference. Now, which of the following features are same and which are different? If you look now to the domain all real number, okay, all real number, okay, or we can say from negative infinite to positive infinite. So for the red, okay, and for same thing for the green, okay. Now the range, okay, the range for the red one starting from 0 to positive infinite, okay, but for the green graph it starts from negative infinite to 0. So they're not sharing same domain, right? Vertex, okay, the red one is 0 and 0, and the green one, okay, also it's 0 and 0. So they sharing same vertex. Okay. Axis of symmetry. If you look to the axis of symmetry of red, okay, it's x equal 0. Okay. And also for the green one is also x equals 0. So they are sharing the same axis of symmetry. Now the minimum of the red one, okay, is equal 0. Okay, which is and the maximum, okay, okay, here maximum is no maximum, okay, none. But for the green one, okay, for the green one, we can say that the minimum of the green graph is none because we have no minimum, but the maximum, okay, it's equal to 0. So now if you look now to this both graph, they are sharing, okay, same features of domain. They are sharing same features of vertex. They are sharing the same features of axis of symmetry. So as you can see here, we have only the range, minimum, maximum are the different things between if we have a positive graph, quadratic, or a negative quadratic functions. Okay, now let's start our lesson 6.2. Before we start, we need to go through this one that I told you in 6.1. I will explain it later. So look to the graph. Okay, if you look now to the graph, this graph is stretched. Okay, so if you catch something, okay, and you stretch it, so it will go, okay, like this. So this is the stretch. So same thing. So and this one here, we call this one as compression or compressed. Okay, what's as you can see, compression has more points close to each other, but the stretch, the points are so far from each other. So now the stretch always represented when a is greater, or let's say when a is is when a is greater than 0, okay, or let's say greater than 1, okay, or equal 1, or let's say greater than 0, same thing, okay, which is, we can say it in different way, the whole, okay, whole number, okay, and the compression, we can say it's a decimal or a fraction. Okay, so when I have a fraction, okay, it's compression. When I have a whole number, is a stretch. Same situation happen if we have a negative. Same thing here. Look to the negative. This one is stretch. Okay, and look to the other graph, which is -1/4. It's also here. It's compression. Okay, so now starting from now, if we have a whole number is stretch. If I have a fraction is compression. Okay, now let's start now, go through the formula. Now the formula, okay, it's a to the power of 2, okay, and no, sorry, not a to the power of 2, I'm sorry, okay, so the formula of the quadratic function or the vertex, so a, let me write here, f of x is equal a times x minus h to the power of 2 plus k. Okay, now let's talk about k. So now k, what's k? Okay, k is the, let's say, the translation, okay, on the y-axis. So always k is related to the y-axis. So now if I have a point, okay, let's say if I have a graph like this, okay, and let's say this one is 1, okay, so now if I say k is equal 5, so that's mean I am moving the points up, okay, to 5 step, okay, so my graph will be like this. Okay, so or let's, if I say it's -2, okay, so now my graph will go 2 step down, which is -2, and my graph will go like this. So as we can see, k is controlling in the translation, okay, on the y-axis, maybe or up or maybe down. So we call this one a vertical translation rather than up or down. So if we have positive k, so as you can see, k greater than 0, which is positive, so that means we translate it up. If k less than 0, which is negative, okay, so that means we translated k to down. Okay, now let's take example to make you understand. Okay, so now if we need to graph the function, okay, so if we need to graph it, we can create our tables and we can memorize the table, which is 0, 0, 1, and -1, -2, and here is 1 and 2. Okay, you replace it, so it will be 4, 1, 1, and 4. Then you can graph your function. So 1 and 1, okay, 2 and 4, -2 and 4. You can convert your function. Okay. Okay, now if I need to graph, okay, number one here, okay, this one. So as you can see here, k is +2. Okay, so now +2 means I need to move every point 2 step up. 1, 2. Every point I have to replace 2 step up. Every point 2 step up. Every point 2 step up. Every point 2 step up. Then after I plot my points, I can graph my functions. Okay, so that's how can I graph my functions. Okay, another way, if I don't want to use my parent function, I can use another way to graph my functions. How can I graph? First of all, identify the h and k. Identify the center. Okay, and we know that this is the formula. Let me write the formula here. So a, okay, x minus h to the power of 2 plus k. So now k always outside the bracket. K always outside the bracket. Okay? And h always inside the bracket. Okay? So now if I need to identify the center, always I identify the center with h and k, right? And h always we take opposite sign. So if it's negative, so I have to take it positive. If it's positive here, so I have to take it a negative. K, I take the same sign. Okay, we take the same sign. So now, first of all, we need to identify my center from the formula. Okay, in all of these equations, we have only K for all questions. So we don't have H. In the next slides, we will have with H. Okay, so now what's the center here? So the center is 0 and k. Okay, so not 0, sorry, not 0 and k. Okay, it's 0. Okay, the center here is 0 and 2. Why h0 here? Because we don't have h. Always, when we don't have h is 0. Also, if we don't have k, also k is equal 0. So if I don't have h and k, it should be 0 and 0. So now I don't have h, I have only k, so h is 0, k is 2. Now make your tables, x, y, okay? In the middle of your table, put the center, okay, h and k. So it should be 0, 2, and pick 2 points less than 0, okay, and pick 2 points greater than 0. Now, replace the points, okay, in the function. So let's replace -1 here into x. So let me do it. -1 to the power of 2 plus 2. So the answer is what? -1 to the power of 2 is equal 1. 1 plus 2, 3. So the answer here is 3. Now let's replace -2. So replace -2 here. So it should be 4 plus 2, which is equal 6. Okay? So now because the axis of symmetry, this one should be 3, this one should be 6. Now if I need to graph my point, let's start. So 0, 2 is here, 1 and 3 is here, -1 and 3 is here, 2 and 6 here, -2 and 6 also is here. Then I can graph my function without using the parent function. See how it's easy? Easy, right? Okay, let's graph this one here. Okay, so now first identify the center. The center is 0 and -5. Now make your table x and y. Okay, so the middle should be 0 and -5 here. Okay, now pick 2 points less than 0. Pick 2 points greater than 0. Now substitute the points in the functions here. Okay, so now 1 to the power of 2, -1 to the power of 2 is equal 1. 1 minus 5 is -4. Now replace -2 here. Let's do it mentally fast. -2 to the power of 2 equal 4. 4 minus 5, -1. So do the same thing. -4, -1. Now replace your point. 0, -5 is here. Okay. Then -1, -4 is here. Okay. 1 and -4 is here. 2, -1 is here. -2, -1 is here. Then you can graph your function. Easy? Right. Okay. Now, if you need for me to do other questions or other examples, call me or just text me, then I will solve you more examples. Here are also 2 examples. Try to do them by yourself. Now let's go to understand K. Okay? So now to understand K, it's similar, okay? It's similar to understand, sorry, H. It's similar to K, but here, H, we are talking about horizontal translation. So if we write the formula, so the formula is A, x minus h to the power of 2 plus k, okay? Now I need to choose, take h, okay? Now, h is always, I told you, opposite sign. So if you have a negative, okay, we go to the left. If we have positive, okay, we go to the right. Okay, when you identify H, okay, when you identify H, always take it as was opposite. So now when H greater than 0, the graph will translate it to the right. When H is less than 0, which is negative, it's translated to the left. So let's say example, if I have a graph, questions like this, okay, now if I have, let's say I have a graph like this, and I have h is plus 2, Okay, so that's mean I will shift to the 2 steps to the right. It's my function will be here. So let's say if I have h is -5, okay, so I have to move my graph to negative to the left, -5 steps to the left. Okay, now let's take this one here. Okay, we can do the same thing by graphing the my parent function. So my parent 0, 0, 1, 1, -1, 1, 2 and 4, -2 and 4 here. Then I can graph my function. This is the parent function. You can go back to know how I can graph it. You can just create the tables, x, y, okay, 0, 0, -1, 1, -2, 4. Same thing here, 1, 1, 2, and 4. Okay, so if you graph it, you will see it like this. Now, you can use, okay, this one here. I told you before, okay, in the previous one, if we have the formula x minus h to the power of 2 plus k, okay, k is outside the bracket, h always inside the bracket. So, and always opposite sign. So now here, opposite sign, and here is negative. So that's mean h is equal what? +1 because it's negative. So I have to shift my or translate my graph to the right one step. Okay, you can do it by graph. So now shift this one step to the right, should be here. This one to the right here. This one to the right here. Same thing here. Same thing here. Okay, now connect between your points. So your graph will be like this. Okay, so do you need to create a table and do it with another way? Yes, we can do it with another way. Okay, now let's create the tables, okay, to do it in another way. So the first, now how can I do it? First of all, create your table, okay? Or first identify h and k. What's h and k here? H and k is, h is 1, opposite sign always. We don't have k, k is 0. Now make your table, x, y. In the middle should be 1 and 0, because 1 is x, 0 is y. Okay. Now pick points. Don't pick any random point or your graph will be very wrong. Okay. Pick points less than 1. Okay. Pick 2 points less than 1 and pick 2 points greater than 1, which is 1 should be always in the middle. So now less than 1 is 0 and -1. Greater than 1, you can pick 2 and 3. Always the center should be in the middle and you pick points, okay, so close from the x. Okay, now let's substitute the number. So let's substitute the 0 here. Okay, let's do it here. So 0 minus 1 to the power of 2 equal -1 to the power of 2, which is equal 1. So the answer is 1. Now let's take -1 and replace it with the x here. Okay, is this. Okay, so now negative, okay, -1 minus 1 to the power of 2 equal -2 to the power of 2, which is equal 4. So this one is 4. So now this one should be 1, this one should be 4, then 1, so 1, 0 is here, 2, 1 is here, 0, 1 is here, and 3, 4 here, and -1, 4 here, then you can graph your function easily. Easy, right? Okay, let's do another one here. Okay, let's do this one. So first step, identify h and k. H always opposite sign. H here is +3, so I have to take it as -3, right? So 0. Then make your table, x, y. Okay, put in your table in the middle, -3 and 0. Okay, now pick 2 points less than -3. Less than -3, don't tell me -2 or -1. This is greater than 3. Less than 3 means -4 and -5. And greater than -3 is -2 and -1. Now replace these points in the functions. Okay, replace it here. So it will be -4 plus 3 to the power of 2. It's equal -1 to the power of 2, which is equal 1. So you write here 1. So now start replace -5. Okay, so if you replace -5, so it will be, okay, -5 plus 3, all of that to the power of 2. So the answer is -2 to the power of 2, which is equal 4. So right, so 1, 4, 1, sorry, here is 1, 4, here is 1, 4. Okay, 1, 4, then you graph your functions. So -3, 0 is here, negative 2, 1 here, negative 4, 1 here, negative 1 and 4 is here, negative 5 and 4 here. Then you can graph your function easily. Okay, so you can use any way. You can use the parent function and move, translate, or you can use the table way. Here are some questions. Try to solve them by yourself.